Hello everyone, guys, I'm Utkarsh and I welcome you all to the session on intermediate SQL queries. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding the group by clause, the having clause, and we'll be also looking at the couple of different aggregate functions. Now, in the sessions prior to this session, we have discussed the basic SQL queries, all right, and we have also implemented the different type of joins. So guys, let's proceed to the SQL workbench. So I'll be switching to the workbench window. So guys, over here we are in the workbench window, right? So in the previous session, we were working on this data set. So we'll be utilizing the same data set for this particular session. So the database that I'll be using is DB demo 1. This is the database that I'm using. I'm having two tables. The tables are I'm having employee 1 with the columns employee ID, which is let's say set to integer and it has an auto increment. Then I'm using the employee name, which is having varchar 100, department is varchar 50, job role with varchar 50, city with a varchar 50, joining date as date, and the salary as integer. So this is the data that we have in employee 1 table. This is the column structure that we have for, let's say, employee 1 table. This is the table schema. And likewise, we have the project. So for projects, the column structure goes like we have project ID set to integer, and then we have the auto increment, and I'm setting this to primary key. Then we have the employee ID, which is set to integer. Then we have project name, which is varchar. Then the start date is date. The end date is date. Means these are the two. This is the project start date and the end date, right? Then we have the status. Status is again varchar. And then I do have the foreign key, which is referring to the employee ID from the same table, right? As in the projects table. And it is referring to the employee ID of the employee 1 table. So this is the structure of the foreign key. Foreign key employee ID means it is referring to this column, which would refer to the employee ID column from the employee 1 table. So this is the common column which connects these two tables. Then I've inserted a couple of rows into the employee data, and a couple of rows are inserted into the projects table as well. So I'll show you the table. So this is the employee table and this is the projects table. All right. Now based on this, let's understand the concept of group by, having, and the aggregate functions. So this is going to be the topic for the session, group by, having, and the aggregate functions. First of all, we'll be starting with the aggregate functions. So when we talk about the aggregate functions, right? So we have a couple of functions such as sum, minimum, maximum, count, and average. These functions are referred to as the aggregate functions. Now they can be applied on different types of columns. For instance, suppose we have some numerical data. So on that numerical data, we can apply sum, minimum, maximum, count, and average. And if we have some categorical data, so there we can apply the count. Even for date, we can apply, let's say, minimum, maximum, and count. And suppose we have columns like maybe sales, maybe profit, then we can compute sum and average as well. So depending upon the type of columns, we can apply these aggregations. So I'll show you how to apply them. And because they are functions, so they'll end up with parentheses. So as the name sounds, sum will be used to implement the summation operation. Min will be used to perform the minimum operation, max for the maximum, for finding the maximum, count for counting, and average for computing the mean. So let's have a look at the table structure. Select star from employee 1. So this is my table structure. So I'm having, let's say, the salary column is present, right? And then the second table that we have over here is projects 1. So from projects 1, these are the details. So I think I've mentioned the table structure somewhere. I'll be writing it over here so that we can track the, yes, we can track the table schema. So this is my table structure or the schema. Now let's understand how to utilize this. So for, let's say, for the salary, can I compute, let's say, the sum of salary and even the minimum and maximum salary? Yes, we can compute this. So over here, if I need, suppose I want the minimum salary, then I'm writing the maximum salary. Next, I'm writing count of salary from the employee table. So let's see this. So these are the aggregated values. The minimum salary from this data set is 34,000. The maximum salary over here is 85,000. and the count of salary that we have over here is 10. So this is the data that we have. Now I can also compute let's say the sum of salary and the average salary as well from the employee table. So these are the different aggregate functions. So let me run this, the sum and the average. So guys, the sum of salary is 6,56,000 and the average salary is 656,000. Now the problem with using the segregate functions in MySQL is that the function name is utilized as the column name as well. So this is where, let's say, aliasing is needed. So what is aliasing? Aliasing simply refers to, let's say, renaming a column. Alright, to better suit the requirements to business problem statement. So I can write it like this, or I can write it like this. So this is as minimum salary. Now over here I can mention maximum salary, and for the count I can mention count of salary from the employees. So if I run this now, as we can see, the column names have been transformed. Now utilizing as is optional. Aliasing simply means renaming a column. How can this be done? Let's say can be implemented with or without or. All right, it can be implemented with or without or. So let's see how this can be managed. So over here I've mentioned minimum salary as minimum salary, max salary as maximum salary, and count salary as count salary. So if I run this, as we can see, the column names have been aliased. Now as the keyword as is completely optional, so even if I do away with the as keyword, the result would not change. So guys, as we can see, the result has not changed. So this is where I'm fetching the minimum salary, the maximum salary, and the count salary. This is what we have. So guys, this is how we can utilize the aggregate functions. Now the benefit of utilizing the aggregate functions comes when we discuss the group by. So let's understand the second concept, which is group by. So we'll be implementing all these operations even in PostgreSQL as well, right? So when we talk about group by, so group by is used to perform aggregations like sum, count, average, minimum, maximum on groups of data. So the group by clause in SQL is used to group rows that have the same values and specified columns into the summary rows like totals or counts. All right. So simply put, group by is nothing but aggregation with respect to some column. This is how we need to utilize group by. So the only rule that has to be followed is the columns, let's say, present in select clause must be present in the group by as well, clause as well. All right, and preferably in the same order. So I'll tell you what it implies. So let's have a look at a couple of examples. So suppose I want to solve a question. Let me check the schema again, table schema. This is my table schema, right? So based on this data, suppose I want to solve select star from employee, and then we have select star from projects, right? So over here, let's say I want to know the maybe city wise average salary. The simplest question over here, I want to know city wise average salary. So how would I write this? How to compute this? To compute this, what can be done over here? I can write select city, because I'm supposed to find city wise average salary, right? So city and then average salary. So this is the this is where the aggregate columns comes into picture, and then I'll call it average salary from the employee table. All right, and then I can mention group by city. So this is what I meant by the columns which is present in the select clause must be present in the group by in the same order. Currently we just have one column, so let's execute this and check. So guys, see, for Delhi the average salary is 68,000, for Noida it is 63,666, for Mumbai it is 64,333. This is the let's say average salary. Then if I want to know, so maybe I can apply the order by for sorting it as well. All right, so over here I can mention order by city. So now it will be ordered in the ascending order of city. So we have Delhi, Mumbai, Noida. If you want it in descending order, so I can mention like this. This would be in the descending order of city. So this is what we have. Next over here, if we have a look, so this is city wise average salary. Next Maybe I want to find the department wise minimum salary. Find department wise minimum and maximum salary. This is what I need to compute. So let's change the query. So I need to write department and then the minimum salary. I'll write it as minimum salary, and then I need to find the maximum salary, and I'll call it as max salary, and from department. So select department comma minimum salary as minimum salary, maximum salary as maximum salary from department. All right. So this department does not exist. What is the column name? I'll check this again. So this is department, right? Department wise. Okay. From, so from would be the employee name, employee one, and then group by department. This is how I need to write this. So guys, just have a look. So for the IT department, the minimum is 68,000, the maximum is 85. For HR, it is 34,000 to 54,000. For finance, it is 65,000 to 85,000. For marketing, it is 81,000 to 81,000 because there is just one employee most likely. And for sales, it varies from 47,000 to 65,000. This is how, let's say, we are computing the department wise minimum and the maximum salary. Now, can we apply aggregations based on maybe multiple columns? Yes. Currently, our aggregations has only one basis, right? It has only one basis, and that is only one column. I've only utilized one column. So let's try to increase the number of columns. What about job roles? Let's have a look at the job roles. So I can use the keyword distinct that returns distinct values from the column. Select distinct job role from the employee. So if I run this, we have software engineer, HR manager, accountant. So we have n number of different job roles, right? Okay, let's not go for job roles. All right, let's do one thing. I'll be computing department and city and department wise, maybe average salary. So find city and department wise average salary. So how can we compute this? Over here, I'll be writing city, comma department, and then average salary. This is the alias from employee one, and then I'll be writing group by city. All right. So now if I run this, I have to write the department as well. So see, the columns I've added in the group by are present in the same order as the columns I've mentioned in the select query, right? So see, for Delhi we have IT, and then this is the salary. For Delhi has only one department. For Noida, again there's only one department, but Mumbai has three departments: finance, marketing, and sales. So these are the values. For Noida, IT is present again. So maybe after this I can order by city. So all the cities will be displayed once. So for Delhi, we have three departments: finance, HR, and IT. This is the average salary. For Mumbai, we have finance, marketing, and sales. So these are the average salary: 65,000, 81, and 47. And for Noida, we have HR, IT, and sales. And this is how the salary varies: 54,000, 72,000, and 65,000. So guys, this is how we can utilize the group by. Next, we have another concept which is referred to as the halving clause. So let's understand the halving clause. So why do we use halving clause? So it is used for filtering. First of all, we have to understand that it is used for filtering, and filtering, let's say, on both aggregated and non-aggregated columns. It is used for filtering on both the aggregated and the non-aggregated columns. So if we can apply filtering on both the aggregated and the non-aggregated columns, so how would I utilize them? Let's understand this, and let's say if used with group by, if it is used with group by, it is written after group by clause. All right, and it can be used without group by as well. So it can be used even without group by. So let's see how this works. So maybe I want to filter this. All right, I want to filter this. So this is my data. Now the problem statement is find department, and I'll give you two examples. So this is maybe question 5. So find department wise minimum and maximum salary, let's say only for IT, finance and HR. All right, so this is what we have. So we have so many departments. Now this is before group by, because there is a condition involved, I can mention where department in IT, HR and even finance. All right, so this solves the problem statement. So we have department, minimum salary and the maximum salary, right? But only for IT, HR and finance. So this is one option. Now if I have another question, I'll take the first example. Okay, so this was I guess example 4. Then the next example would be find city wise average salary, where average salary is let's say where the average salary is greater than 60,000. This is my requirement. So now we cannot solve this using the where clause, because the where clause would not work on the aggregated column. So if I were to write where, let's say the average salary is greater than 60,000, so it's not going to work. You can check this, it's not working, right? So now if you think that maybe this will work, so even this is not going to work, because where clause is not meant to be applied to the aggregated columns. So even this is not we cannot apply this. So what is the other alternative? The other alternative, let's say this is incorrect, right? This is the incorrect approach. So what is the other alternative? The other alternative that we can use over here, this is question 6. All right, so so the same question solved correctly. How would I utilize this? Find city-wise average salary, where the average salary is greater than 60,000. So I'll be writing city-wise average salary as average salary from employee 1. All right. What is the condition? Where is not meant to be used. Over here we'll be using group by city, and then having the average salary greater than 60,000, and then maybe I can mention order by city descending. So now this solves the problem. So as you can see, now the average salary is greater than 60,000 only. All right, so this is how we can utilize the having clause. Now can the having clause be used instead of where, like this? Yes. So this is one approach of solving it. The another approach of solving the same problem could be, another option could be, I can write it this entire thing in the where clause. So after group by we can mention the having department in this. So even this solves the problem. So what where can do can also be implemented using having. The only constraint being the column onto which having is applied must be present in the select clause. All right, having requires the column to be present in the select clause on which, let's say, filtering is applied. So guys, this is how we can utilize let's say the having clause as well. So we have seen the example, we have seen the differences between the having clause and the let's say where clause. So guys, moving forward, let's implement the same in Postgre. So guys, this is where we are in the Postgre, and this is the data that we have. So I'll show you the data. We have the customer table having customer ID, customer name, city, gender, email and job. And then we have the orders table having order ID, customer ID, order date, product name, quantity and price. So this is the data. I'll show you the data. So we have the customers and the orders. See, what are the columns in customer table? We have customer ID, then we have the customer name, then we have city, then we have gender, then we have email, then we have job. All right, so these are the columns from the customer table. Then next, if we look at the orders, So in the orders table, I'm having order ID, then we have the customer ID, then we have the order date, then we have the product name, then we have quantity, and then we have the price. Uh, so this is the data that we have. Now based on this, first we'll be looking at the aggregate functions. So how to use the aggregate functions? Again, we do have the same functions. Over here I can write, maybe select, I want to find, let's say, sum of quantity for the product. So the problem is sum of quantity, not just sum. Okay, instead of writing the, let's directly write the query. Over here I want to find minimum quantity, then the maximum quantity, then the sum of quantity. So the column name is quantity, right? I'll have to write the entire name. This is quantity, minimum quantity, maximum quantity, then we have the sum of quantity, then we have the average quantity, and we have count of quantity. And from the table name is customer 1. So let's run this. So if I were to execute this, minimum quantity, okay, this is not present in quantity, it is present in orders 1. So guys, as we can see, the minimum quantity is 1, the maximum is 4, the sum is 37, the average is 1.6, and the count is 23. So we have 23 total records. This is how we can use this. Now how to provide alias. So for aliasing, I can simply mention, like maybe for maximum quantity, I can simply mention, let's say, max quantity. All right, for average quantity, I can mention average QTY. So now as you can see, this is the max quantity and this is the average quantity. So the aliasing has been applied, right? So this is how we can deal with the aggregate. Next, let's talk about group by. So when we are talking about group by, we have to understand that again we have to perform aggregation with respect to some entity, right? So suppose I want to find product wise sum of quantity sold, and this is based on the product. So how can we implement this? To implement this, we can proceed like this. Select product wise sum of quantity, product wise sum of quantity, all right, as some quantity from the orders table, and then group by. So in group by, I have to mention the product. So let's execute this. So this is from, okay, we don't have product, or what? We have product name. So the column name is product name. So now if I were to execute this, so guys, as we can see, just check, laptop stand has been ordered once, smartphone ordered thrice, mouse has been ordered 6 times, smartwatch once, tablet 5 times, wireless earbud 3 times, keyboard 5 times, and likewise. So this is how, let's say, we can apply group by, and it can also be applied on multiple columns, but as far as this data is concerned, currently we are using this. So maybe I can check for quantity, we can check the price as well. So maybe I want to find, let's say, product wise total sales. So how to find product wise total sales? So again, the same logic, we'll be using this. All right, I'm writing select product name and then sum of quantity into price. This is what we need to obtain. So sum of quantity into price would be the total sales. This is going to be my total sales. For each product, what is the total sales? So maybe the question is find product wise total sales. Find product wise total sales, sort it in the descending order. So guys, if you just have a look, we have laptop stand 12,000, smartphone has been sold for 60,000, mouse for 6,000, smartwatch for 8,000, tablet for 90,000, wireless earbuds for 7,500, keyboard for 7,500, monitor for 88,000, laptop for 2,60,000, and power bank for 5,500. So guys, this is the total sales. This is the total sales. Now besides the total sales, I want to know the sum of quantity as well. So even this can be applied for each, let's say, total sales and total quantity. All right, so I'll be mentioning this is the total quantity ordered. So for each product, what is the total sales and how many times it has been ordered, we have extracted over here. Next, we'll have a look at how to use the having clause. Now, from the same data, suppose I want to filter. The problem statement is find product wise sum of quantity sold. Find product wise sum of quantity sold, where let's say the sum of quantity, let's say, is more than one. All right, okay, let's say it's more than two, where the ordered quantity is more than two. So we cannot apply this using group by, right? So we have to apply it using having. So this is how it can be applied. Let's check this. So guys, as we can see, this is where these are all the orders of the product wise sum of quantity, where the ordered quantity is more than 2. All right, so we don't have any ordered quantity that is less than or equal to 1 or 2. So guys, this is how, let's say, we can utilize even the having clause. So can we apply it, let's say, for some other filtering? Let's check. So maybe this is what I have. Let's execute this. Now over here I want to filter having product name in, so maybe laptop. I want to filter laptop, then mouse and the keyboard. So these are the products which I wish to filter. Let's see. So guys, as we can see, having can also be used. So this is case sensitive, so laptop would be capital L. So guys, as we can see, we are also able to apply having on non-aggregated columns. So why are we using having? Let's say having for filtering on aggregated and non-aggregated columns. For both these, let's say, scenarios, having can be utilized. All right. So maybe we can have another example. All right, where suppose I want to filter this and I want to apply some where clause along with the having. So this is what we have, and I'll be writing this in the where clause. So where product name in this. So I'm only concerned about, maybe let's say we have a smartphone. Let's see. So guys, we are extracting keyboard, laptop, mouse and smartphone, and these are the only products that I'm interested in, so I filtered using the where clause. And then the problem statement was to extract the sum of quantity where the sum of quantity is greater than 2. So this is the query where we have used the select clause, the where clause, the group by, having, and we have also utilized maybe the order by. So I can order it by the product name and maybe in the descending order. So all the clauses can be used in the same query as well. All right, so guys, this is how it can be utilized. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session, we have understood the concept of the group by clause. We have understood how to utilize the having clause, which is essentially meant to filter on the aggregated columns, right? Then we have also understood the concept of utilizing different aggregate functions, namely sum, minimum, maximum, count, and average. So guys, in the next sessions, we'll be moving to the subqueries concept. Thank you.